Hello and welcome. Thank you for taking the time to better understand our Cisco products. Today, I'm going to be talking to you about the NCS 55A1 24Q 6H-SS. This is the latest addition to Cisco's NCS 5500 portfolio, which is a part of our mass scale infrastructure group. This chassis is a 1RU fixed form factor and is powered by a single Broadcom Jericho Plus NPU with large LPM. It has 48 ports of SFP and 6 ports of QSFP. Out of the 48 ports of SFP, half of them, that is 24 ports, are capable of doing 25 gig, and all of them are capable of doing 1 and 10 gig. The box has timing support on all the ports and has front-to-back airflow. It supports MACsec as well on all ports, and hence is a perfect deployment where security may be of higher concern. It can be used in various parts of your network that include but are not limited to pre-aggregation and aggregation roles. It can be deployed in sectors such as finance, banking, healthcare, remote PHY, enterprise, and public sectors wherever, again, security may be of higher concern. We are shipping this box today with the latest version of XR, which is XR721. So talk to your Cisco sales rep and ask them how NCS 55A1 24Q 6H-SS can fit into your network and help make it more secure. Thanks again for your time.
Hello, my name is Bernhard, and I want to introduce you today to what we have done on our optics lineup on NCS 5500 with iOS XR721. The work has been impacted by COVID-19, as you may expect, because optics testing is a lot of hands-on work, and COVID-19 restricted us with our lab access. Nevertheless, we achieved a lot. We added a lot of optics support to our NC55-36x100 line card, our MACsec line card. There was light-in optics support in the past. We added 4x100 gig breakout support to our Big 400 line cards. And together with that, the 100 gig FR, the corresponding optics on the other side of the 4x100 gig FR, 4x100 gig breakout. We added 25 gig optics to a number of line cards. We added some 10 gig optics, 10 gig tunable to a number of products, and some 1 gig optics in the end made it also. And also, first time we introduced 10 gig copper on our NCS 5501. That's the first product with 10 gig copper support on our complete lineup. All of this you can see in the TMG matrix. Please take a look at that. You will see it there.
Okay. In 721, we will support WAN-Phy on the NCS 5500 MPA. Basically, WAN-Phy will add a solid layer between Ethernet MAC PCS layer and the PMA PMD layer to adapt the rate of the LAN-Phy to the WAN-Phy speed, which is slightly lower. In the first phase, we support only the LR 10 km reach optics, but in 722, the second phase, we support the short reach and ZR long reach as well. WAN-Phy supports better performance monitoring and alarms handling than LAN-Phy. Let's look at how WIS layer do the rate adaptation. Since LAN-Phy will be running faster than the SONET layer, the WIS will insert extra byte in the interframe gap to adapt the rate of the MAC layer to the SONET layer.
Hello everyone, my name is Paban Sarma and I am a technical marketing engineer with the MIG business unit at Cisco Systems. Today I am going to talk about the shared polyser feature introduced in iOS XR release 7.2.1 on the NCS 5500 platforms. This feature allows one or more traffic classes in a single policy to share the same polysers. Thus, it enables user to have an aggregate policing rate but with a different marking profiles. The sharing of polysers is restricted to the same policy map and attachment point. That means if I have a polyser applied to an interface 1, then I cannot share these polysers on a separate interface 2. For the statistics, by default, all the shared classes, the statistics is displayed in aggregated mode. However, with an hardware module profile, we can view the traffic statistics for all the traffic classes. For the demo, I have one NCS 5500 box running iOS XR 7.2.1. Traffic is entering via interface 10GG18 and going out of interface 10GG20. I have a shared polyser installed on interface 10GG18. So this is the box running iOS XR 7.2.1, and I have installed the policy map shared polyser interface 10GG18. If I look at the programming, I see polyser bucket ID 0x82 is programmed for class P2, and I am marking it with traffic class 2. For class P3, I have the same polyser bucket ID, meaning that this 100 Mbps polyser is shared between class P2 and P3, but I have a different marking profile for both of them. If I check the policy map statistics, here I see statistics on only class P2. All the statistics for class P3 is 0, although I have enabled both the flows. This is because I am not using the per class mode, and by default, the statistics is displayed as aggregated. In a second box, I have enabled the US polyser per class statistics, and if I see the stats here, I can see the statistics are displayed for both the class P2 and P3. The Conform aware hierarchical policy feature introduced in iOS XR 7.2.1 on NCS 5500 platforms brings color awareness to the parent polyser in a hierarchical policing. The parent polyser is color aware here, and the color is determined by the child polyser conformance. So this guarantees that the child committed information rate are met at any condition, provided sum of my child CIR is less than my parent CIR. If a packet is marked as exceed or yellow in child, then it is not upgraded to conform in the parent policy. This feature also allows child to share the unused CIR from one class to the other. This feature needs to be enabled using a hardware module profile QoS conformable polyser command, and this needs the box to be reloaded. Let's check this feature with a quick demo. I have one NCS 5500 box running iOS XR 7.2.1, and traffic is coming into interface 10GG20. I have a hierarchical polyser installed on this interface. It has two child class with policy rate of 70 Mbps and 30 Mbps on each. The peak rate on each child can go up to 100 Mbps. The parent polyser restricts everything to 100 Mbps. With the child conformance enabled, all my child, the CIR will be always met. I am running the traffic from my TZen, and I am running 150 Mbps of traffic on each class. I can see my aggregate rate is 100 Mbps. This is because my parent polyser peak rate is 100 Mbps. If I drill down to the per class level statistics, I can see for my class cost 2, I am getting around 70 Mbps, which is the CIR of child class P2. And for IP precedence 3, that is my class P3, I am getting a receive rate of around 30 Mbps, which is my CIR for class P3. The Egress shaper burst feature allows user to configure the peak burst for a shaper. By default, the shaper peak burst is 32 kilobytes irrespective of the shape rate. With the new feature introduced, the configurable range of burst size is 2240 bytes to 64 kilobytes. This shaper burst size and the shaper rate results the peak rate for that particular traffic class. Let's verify this feature on a live router. I have a box running 7.2.1, and I have a policy map where I have class TC2, TC3 and class default. All of them are saved to 100 Mbps. I have not specified any burst for class TC2, and I have specified burst size of 10 kilobytes and 64 kilobytes for class TC3 and class default. This policy map is applied to interface 10GG18, and if I verify the hardware programming, I can see the default peak burst that is programmed is 32 KB, which is 3600 bytes here in the hardware. Then for the other two classes, the peak burst is as per the configured values.
Hello everybody, my name is Neeraj Garg. Present of today's discussion to talk about the load balancing of the GTP tunnels over MPLS transport. GTP tunnels which are established over IP MPLS network should get load balance based on inner GTP tunnel ID. Uneven load balancing of the traffic is seen in absence of GTP ID in hashing key because UDP port, the SIP, the DIP in L3 header remain same for a GTP tunnel. Under this feature, only transit traffic with GTP payload is handled by a FATA family of routers for load balancing improvement. The scope of this feature is for all FATA family of routers except Jericho 2 based routers. Let's understand GTPU header fields. If we focus on GTPU header, we can notice GTP ID or TEID field. The TEID field unambiguously identifies a tunnel endpoint in receiving GTPU header. This TEID can be used for hash key generation per GTP tunnel. By default, load balancing based on GTP ID when GTP tunnels is over MPLS is disabled. To enable this feature, new CLI hardware module profile load balance algorithm GTP MPLS should be configured. Reload of the router is not required after configuration of the CLI. Number of MPLS label stack in transport layer is limited to 3 for considering GTP hashing. GTP hashing is not considered when MPLS label stack is beyond 3 labels. Thank you. Agenda of today's discussion is to talk about UCMP over MPLS-TE. With UCMP load balancing enabled, the protocols can use even lower bandwidth paths or say higher cost paths for traffic and can install these paths to the forwarding database. Forwarding database utilizes the weight to decide the amount of traffic that needs to be sent on higher cost path and amount of traffic that needs to be sent on a lower cost path. In the following example, there are 3 paths to reach to network X. If we count the cost of the path, EBA is 40, ECA is 50, EDA is 40. Even though paths have unequal cost, using UCMP, we can use all 3 paths with traffic distribution based on their weight assigned. Under MPLS traffic engineering, we need to configure load share unequal. Under interface tunnel configuration, we need to configure load share weight. Under SOCEF IP, we can cross-check weight assigned to a path, normalize weight calculated by FIB, and load distribution for the paths. To talk about platform capabilities, L3 hash bucket size is 64. That means normalized weight path can be maximum 64. There is no change in ECMP FAC usage with respect to UCMP enablement. Irrespective of ECMP or UCMP configuration, per path group, we will use only one ECMP FAC from the hardware resources. This brings to the end of this feature training. Thank you.
Hello everybody. Today we will talk about chained or common ACL for NCS 500 and NCS 5500 series platforms. Prior to 7.2.1, we were supporting only one ACL per direction per interface. This feature aims at giving the customer flexibility of configuring more than one ACL on a single interface, as well as saving the TCAM resources. Today, we only support one common ACL in Egress direction. Common ACL is searched before the interface ACL. Let's have a quick demo on how to configure this feature and see how it benefits the customers in saving the TCAM resources. I have an ACL configured which is having around 10 ACEs. I have a similar ACL which has around 9 ACEs. I will try to apply this on the interface. I'll apply the other ACL on another interface. Let's see the utilization of the TCAM by applying both the ACLs. We can see there are 34 entries in the TCAM. If you see these entries, most of the entries are common between both the ACLs. So to save TCAM risk and to utilize the resources optimally, we can configure a common ACL along with the specific ACLs to save the TCAM resources. We will see how to do that. Let's configure the common ACL along with the interface specific ACLs. Common, and then we have to give the name of the common ACL. Then we give the name of the interface specific ACL and the direction. Similarly, I will apply another ACL using the same common ACL and ACL2. Let's see the TCAM utilization now. You can see instead of the previous utilization of 34 TCAM entries, we are utilizing now only 26 TCAM entries. So this eliminates the use of multiple ACEs in a single chassis, and we can use this feature to reduce the TCAM usage. The second feature I will talk about is ACL support for IPv6 fragment. Fragmentation occurs in a network when we have interfaces with varying MTU sizes. Non-initial fragments typically escapes the AC match because they can be blocked only on the basis of layer 3 information. With the introduction of this feature, we will be able to match those fragments and filter them out. This particular feature was already supported on IPv4. From 7.2.1, we are extending the support for IPv6 as well, only on systems with Jericho 2. We can see a sample configuration where we have a deny ACE to filter out the non-initial IPv6 fragments, and we have a permit statement to allow legitimate traffic which is non-fragmented.